Okay, our lesson now will be a linear combination of vectors. That means we can write one vector in terms of other two vectors. To do this, first we have to understand that we have two-dimensional and three-dimensional. Vectors can be represented in two-dimensional, like what we have seen in xy coordinate only. So we say if this is let's say 3, 4, that means a vector. This vector is called a position vector. Position vector from O to the point P, this is called position vector. So it's two-dimensional. In two-dimensional, we have the basis unit vectors called ij. So we can call OP can be written as vector 3, 4, or OP can be written as 3i plus 4j. I and j are bases for vectors. I and j are unit vectors, which means the coordinates of I is 1, 0. It's on the x-axis, but it's a unit vector. J is on the y-axis, which is 0, 1. We can have three dimensions. Three dimensions means the three of them are mutually perpendicular to each other. So this solid can be represented in three dimensions. So x, y, z. We have three unit vectors, I, j, and k. These are called unit vectors. So let's say if I have a point, like if I have a vector 2, if OP is 2, 1, minus 2. How do I draw this one here in three dimensions? So x is 2. x2 means it's in the positive direction. Let's say first the three dimensions here. This is x, y, z. X is 2 means I go 2 units in x. And then y is 1 means I go 1 unit this way. So 1 unit is here. And then negative 2 means z is down. So this is that. It's down by 2 units. 2 units down. Okay, so this is my final point here. So I can make a box here. Okay, so this is my position vector. This is called position vector OP. Okay, once we know R2 and R2, so we can write one vector as a linear combination of two other vectors. So I can say, write -1, -9, -13 as a linear combination of two vectors, 1, 2, 4, and 2, -3, -1, which means I can write as a linear combination of two vectors. This happens only if we have non-zero and non-collinear vectors. So I can check these are non-collinear. Non-collinear means one is multiple of the other one. Zero vector means these are all zero vector. So none of them looks like collinear, but let's check. So to write as linear combination, what we say is, let's write -1, -9, -13. If this is equal to a scalar m multiplied by 1, 2, 4 plus scalar n multiplied by 2, -3, -1. So I'm finding two numbers where multiplied this to this, multiplied n by this. I add them, I can get this vector here. let's try. So the first number, which is -1, must be equal to the sum of the first two numbers, which is m times 1, m plus 2n. And the second number, -9, must be equal to 2m minus 3n, and -13 must be equal to 4m minus n. So I would like to eliminate a variable from any two of them, solve m and n, and substitute those numbers into the third one, which I did not eliminate or I did not use. So let's do the first two. From the first two, I can multiply the first one by 2. So it will be minus 2 equal to 2m plus 4n. And the second one is -9 plus 2m minus 3n. Since I have the same sign, I subtract. Therefore, I will get -2 minus -9 will be 7. 4 minus -3 will be 7. Therefore, n equal to 1. Once I get n equal to 1, I substitute into the other equation, one of the equations. So -1 I substitute there. -1 equal to m plus 2 times 1, which means m equal to -1 minus 2, which is -3. So I got m equal to -3, n equal to 1. I take these two numbers, I substitute them onto the equation I did not use. I did not use the third equation. Therefore, I check if these numbers make them equal. So I take the third equation, which is -13 equal to 4m minus n. I say the left side of this is -13. The right side is 4 times -3 minus 1. Okay, so which is -12 minus 1, which is -13. So left side equal to right side. Therefore, my numbers are right. So what I do is I take these numbers here, I write the equation. I take the equation -1 minus 9 minus 13 can be written as m, which is -3, 1, 2, 4, and then plus n is 1, which is 2 minus 3 minus 1. Or if I gave this ones like w vector, and this was u, and this was v, I write vector w is equal to -3 times vector u plus 1 times vector v. And this is linear combination, which means that the vector lies, this vector lies on the plane formed by the other two vectors. The third vector w lies on the plane, so we say it lies in the span of u and v. W lies on the span of u and v. Or we say they are coplanar, means they lie on the same plane. Okay, so this, in order to be coplanar or in order to be written as linear combination, they must be non-collinear and non-zero vectors. Okay, that's it. So please don't forget to subscribe to get the next lessons.